In the context of a warming planet, access to cooling in many parts of the world is increasingly viewed as a societal need, supporting positive health outcomes, higher productivity, and accelerated economic development. However, in a world where over 3 billion people lack access to cooling, meeting this need will come at an environmental cost that we simply cannot afford. This is the dilemma that the Global Cooling Prize set to solve. So in 2018, RMI, along with the Government of India and Mission Innovation, launched the Global Cooling Prize to spur private sector innovation to identify residential cooling solutions that have 5 times lower climate impact than standard air conditioners sold in the market today, all without compromising comfort or affordability. Why 5 times? Simply, this was what we calculated as necessary to neutralize the climate impact of the inevitable growth in cooling over the next 3 to 4 decades as the gap in access to cooling is closed. So the prize was not about incremental improvement, but identifying breakthrough technologies that could completely solve the cooling dilemma. And to be clear, 5 times lower climate impact means 5 of these new cooling solutions would have the same climate impact as just 1 of today's standard air conditioners. Over the following 12 months, we received 139 detailed technical applications from 31 different countries, from which we selected 8 finalists to move to prototype development.
From the United Kingdom is Baracol Limited.
Hello, my name is Javier Moya. I'm Director of Research for Baracol, a startup company that has recently spun out from my research laboratory at the University of Cambridge. In many ways, we are trying to pioneer innovative zero carbon emission refrigeration. So the materials behind this technology are barocaloric materials, and these materials can display thermal changes when you apply and remove pressure to them. So in a typical cooling cycle, you will apply pressure to the material and the material will warm up or release heat to the environment. And then when you remove pressure, the material will cool down or absorb heat from the environment. And then you can combine these different steps to make a cooling device. So in many ways, our technology is analogous to vapor compression. But in vapor compression, you drive transitions between a gas and a liquid phase using pressure, whereas we actually drive phase transitions using pressure between 2 different types of solid phases. This has the benefit that the material is not going to be volatile, so it's not going to contaminate the environment or contribute to global warming. If you compare these organic materials with any other type of caloric material, which is shown here in green, we have achieved order of magnitude improvement in performance. Our core innovation provides a disruptive technology that uses large barocaloric effects in inexpensive barocaloric materials that are organic. These refrigerants are easy to scale up in terms of production, and they also permit to construct thermodynamic cooling cycles that are highly energy efficient. One component is a pressurized chamber where we can apply and remove pressure to the barocaloric refrigerant, and then we have a secondary circuit for heat exchange, which uses an inert fluid such as water. We are developing the technology, but we are also open for partnership with air conditioning companies and other cooling companies. And just let me finish saying that we are really thrilled about being one of the finalists. This is both very stimulating and a big challenge for us, but we love a challenge, so let's see what we can do in the next few months. Thank you very much.
Team Daikin Air Conditioning India Private Limited, Daikin Industries Limited, and Nikon Seiki Limited from Japan and India.
My name is Gaurav Mehtani. I manage product management and the technical support part in Daikin India, and I also manage the energy efficiency activities in Daikin India. We have collaborated with Nikon Seiki, which is the topmost consulting organizations of the world.
Yet another example of your team disrupting yourselves and asking what you can do even more. You have a low global warming potential refrigerant already on the market, and you decided to go even lower, is that right?
Still lower, yeah.
Firstly, we will adopt multi-split method to connect 3 indoor units with 1 outdoor unit. This method optimizes refrigerant flow for each of the 3 units depending on ever-changing cooling load and using refrigerant control technology to closely modulate the latent heat and sensible heat capacity.
Also in this system we are using evaporating cooling method, which basically supplements in the energy efficiency domain and which basically helps to achieve the score that we achieved in the Global Cooling Prize.
In order to reduce the annual power consumption, we first selected efficient components, and for each item we optimized the design of the machine to improve the airflow performance. In response to cost requirement, we shall optimize the cost of the components in terms of efficiency and other related parts. So that's what we believe. Eruption, disruption, and then explosion. Daikin will put its best foot forward to develop working prototypes in the next phase of GCP.
I am Suhas Kulkarni. I work for Godrej Appliances. I am responsible for R&D and I work from Pune. Godrej was the first company to make refrigerators in India, setting the foundation for appliance industry in India. We had very clear approach how to go about Global Cooling Prize. With the focus on environment, which is essentially on a green and efficiency, Godrej has done lots of pioneering initiatives in this field. We decided to work on well-established technologies and well-experienced partners so that the risk to the solution is minimum.
What is our concept? Concept is an innovative cooling system which leverages natural refrigerant, zero ODP and very low global warming potential to minimize climatic impact. We would be highly optimizing our vapor compression cycle and will integrate it with advanced evaporative cooling cycle.
To manage this marriage and extract efficiencies further, we also decided to develop a smart electronics, which really helped us to get maximum efficiency, and that's what we are submitting for Global Cooling Prize. India is a warm country and it is getting warmer year after year. I think that's a fundamental reason why cooling is necessary. Since we are environmentally conscious and we always work in this area, we thought if somebody has really put this challenge, it's worthy to really at least make a serious attempt to really achieve it. The choice of the technologies and our whole strategy about choosing the technology and a partner, I think it gives us a very good chance to go right through till the final and win the award.
I'm Bolong Wang from Tsinghua University. I'm associate professor. Today I say hello to you from Beijing. In our team we have two organizers. One is the green. It's the biggest producer of the room air conditioner, and another organizer is Tsinghua University. In developing the technical roadmap, we consider more than a competition criteria. We consider the adaptability of the technology. The high performance of our solution can be reached by three-level innovations.
First one is the system level, which means we cannot just look at the machine, we should step back, look wider. What if we can use more, as much as possible of the free and sustainable energy?
Secondly, cycle innovation. In our system, we use a temperature and humidity independent control cycle. By that cycle, we can largely enhance the average evaporating temperature. Thus, we can reach a relatively higher COP of energy efficiency of the system.
And thirdly, the high performance components, very specific compressor and heat exchangers.
Actually, our solution is an advanced air conditioner integrated with the evaporative cooling and PV panel. Currently, even many of the government cannot reach the agreement. We just do our best. We solve that problem from the technical view. We are excited to provide cooling for all without warming the planet.
Hello, I'm Vijay Mittar. I'm Chief Technology Officer at Kraton Corporation based in Houston, Texas. Project Nexar Cool is based on two wonder materials. The first one is water. Water has a very high enthalpy of evaporation, among the highest in fact. The second wonder material called Nexar polymers developed by Kraton. Now what is unique about Nexar polymer is that it is able to transport moisture very efficiently. So what we do is that we draw the air from room and it passes through the evaporative cooler in which the water gets evaporated and the air gets cooled, but at the same time it gets humidified. Now this cold humidified air enters into the dehumidifier where the humidity is removed, and now the dry cool air enters back into the room.
And what is unique about this Nexar polymer is that it is able to transport air from low humidity to high humidity against the natural diffusion. And that is at the core of our innovation. That is what allows us to operate effectively in high humid environments, whether it's New Delhi, whether it's in Mumbai, or whether that is in Houston.
Our cooling solution is unprecedented in terms of energy efficiency. It is not easy to disrupt a solution that was invented back in 1902 by Willis Carrier. Nexar Cool has the potential to disrupt that, and we are committed to it.
My name is Ryan Melsert. I'm the CEO of M Squared Thermal Solutions, and we're based out of Boston, Massachusetts. The vapor compression technology used today was invented back in the 1850s, and there really has not been a disruptive innovation since then. So this industry is very ripe for innovation. We see there's huge potential to make not just incremental, but a step change in the efficiency of these units.
So we came up with a design where we said, we know that we don't want to have a single system with a single degree of freedom where we cannot independently address sensible heat and latent heat. So we intentionally had two separate components that could independently control both the temperature of a confined space and the moisture of a confined space.
In doing so, we've dramatically lowered the energy consumption of this technology. So our integrated system now uses absolutely no refrigerants, has no high power consuming compressors or high pressure pumps, and is able to achieve an over 500% increase in energy efficiency over today's vapor compression based cycles. Developing a system that has this large of an increase in efficiency is really important because we see that we are at a tipping point globally, that while climate change may seem like it's a long-off problem, when we look at the data, we only have a handful of years left to really address this. We can't be putting this in the back of our minds and hoping to solve it at some point. Now is the time for innovative components to be developed so they can be implemented and commercialized by the time we really need to address this issue.
My name is Sorin Grama. I'm CEO of Transera, and we're located in Boston, Massachusetts, USA. So our team is comprised of pretty experienced engineers, entrepreneurs, we have scientists. We're a pretty small team. We partner with Haier in China and Emerson in India, and my previous company, Promethean Power Systems, to help us deliver on this challenge. Here's our basic concept. Humid air is difficult to cool because of all that water vapor that's in the air. When you cool the air, you also have to cool the water. If you can extract the water vapor first, you can make the whole process much more efficient. Our team has developed a new material that can absorb more water than any other material out there. A material that is molecularly tuned to absorb water and release it effectively, so we can remove the moisture from inside space and move it outside. More importantly, it can remove that moisture using energy that is otherwise wasted. With our partners, Haier, Emerson, and Promethean, we're developing a hybrid mini-split air conditioner with an add-on device that we call a moisture storage battery, which incorporates this novel material. The device will increase the efficiency of the entire system. I lived in India for a number of years, right here in Delhi. I had a staff member, a single mom who wanted to provide better living conditions for her daughter. And I gave her an air conditioner. We had an extra air conditioner. I gave it to her. And a few weeks later, I asked her, I was very excited to find out how it's going, how she liked it. And she looked at me sheepishly and she said, we're not using it because it's too expensive to run it. I realized then that cooling is actually a luxury, and I was a lucky person to have cooling in my house. That's not the case for everyone. This is really important, it really matters, and we're motivated by that.
It probably took about 45 days in a field and 9 months in a lab to conduct the entire test.
This is the state-of-the-art facility designed for rigorous evaluation of finalist prototypes received under Global Cooling Prize competition. Let us have a look inside why this facility is so special. This is our outdoor chamber where we maintain outdoor conditions of the space. These are high accuracy energy meters where we monitor the unit energy consumption. We mounted different indoor units in here. We are measuring the supply temperature and RH and return temperature RH of the units. What you see here in the center is an ultrasonic humidifier. This is a globe temperature sensor which is connected to building management system, so we can actually operate the chamber to maintain a certain specific globe temperature sensor.
Hello everybody, I am absolutely thrilled to be with you all today for the Global Cooling Prize Grand Awards ceremony. These past 30 months have been challenging for everybody, so it's particularly heartening to be at an event like this, where we're showcasing our resilient spirit and our determination to keep doing work that's important for our beautiful world. When RMI, Mission Innovation and the Government of India launched the Global Cooling Prize a little over 2 years ago, they did so recognizing the enormous climate threat that comes from the growing demand for air conditioning. Our planet is getting hotter at an alarming rate, and increasingly people in the hottest regions of the world are talking about affordable cooling as not a luxury, but a necessity. But keeping ourselves cool comes at an environmental cost that we simply cannot afford. And unless we course correct right now, we're looking at a rise in global temperatures of 0.5 centigrade by the end of the century due to residential air conditioning alone. Well, the Global Cooling Prize emerged from a recognition of this need. It invited innovators and manufacturers from around the world to rise to the challenge. 8 of the most promising technologies were selected to receive support for the production of their prototypes. Those 8 became the finalists. But look, I want to first congratulate all the finalists for responding to this call to action. You have demonstrated your readiness to step up, your capacity to go above and beyond, and your commitment to a larger cause. Going over the work you have put in for this prize has filled me with pride and excitement, because I can see vision, I see diligence, I see precision, and above all, I see hope. The criteria were very specific. We're not just talking about an efficient air conditioner, but one that has 5 times less climate impact than the standard unit on the market today, while also being affordable and scalable. Following rigorous testing over the last 6 months, the Prize's Technical Review Committee adjured to review the performance of the finalist prototypes. And I'm overjoyed to announce that not 1, but 2 teams have succeeded in meeting the parameters outlined by the prize and are so close in performance that they cannot be separated. Yes, ladies and gentlemen, we have not 1, but we have 2 winners. And so, without further ado, it is my pleasure to announce the winners of the Global Cooling Prize. And the winners in alphabetical order are Team Daikin with partner Nikon CK and Team Gree with partner Tsinghua University. And I just want to say congratulations to both of you. I just want to say that your innovative technologies show absolutely incredible promise, and I'm sure they will be further developed and refined. And we wish you all every success in the journey forward. The road to realizing one's dreams can be a bumpy one, but that's precisely why we innovate and why we try again and again to figure out how to navigate the twists and the turns on the path to our goals. As this incredible achievement begins to be recognized and applauded, it's time for regulators to focus on the policies and standards that will help us bring these technologies to the market. finally, thank you all for being here today. I hope you're as inspired as I am. And here's to living on a cooler planet. And I just want to say, have a great day or great night, everybody. Thank you so much for being with us, and best to you all. Cheers.
The two winners also happen to be two of the world's largest manufacturers of cooling products. Daikin with partner Nikon Sakai, and Team Gree with partner Tsinghua University. And they showed us what is possible, but our work is not yet done. Through this process, we have learned that the standards we use to assess efficiency that were developed in the global north do not work so well in the global south. With 1/3 of the performance improvements of the winning units were not able to be captured under the ISO SEER testing protocols. These relate to efficiency in dealing with latent loads or humidity, and units typically operating at much lower aggregate capacity levels than those measured and extrapolated under SEER protocols. This has to be addressed. We also need to fuel a race to the top with policymakers, where we look to develop performance ladders with reference to the ceiling of performance, as opposed to the worst available technology or the floor of performance, as is undertaken today. In short, innovators and industry have done what we asked them to do. We now need policymakers to act in this, the decisive decade.